Chapter 15 of SDM4 concerns itself with the construction and the study of the properties of random variables. It begins with the idea of expectation. We've seen that as well in terms of the mean. Here we'll talk about that in terms of centrality for a random variable that gets defined. Here we start with the idea of a discrete random variable, one that takes on a discrete set of values. So it's important to kind of work through these calculations, kind of thinking a little bit of how insurance works. There's another one we could think about with another example. That's good, and I would encourage you as always to take a look at the just checking. So that's the idea of the expected value. We can also think about the spread, the equivalent of our center for random variables, because the expected value isn't going to occur for any particular policyholder in that example. It could in some, but the idea that no one will have 1.7 kids. So we think about the standard deviation as being a function of the variance of a random variable, and all our calculations are done in terms of the variances. So here we can find the standard deviation by taking the square root of that variance, and there's a step-by-step example for this, a tree diagram that steps us through it. So this all requires fairly careful reading. We can think about shifting and combining random variables. There's some additional rules we can be getting for this idea of the expected value of x plus or minus a constant c, some known value. And we get the same kind of thing in terms of the variance. If we actually go ahead now and think about expected values of sums, expected value of e of x, there's a kind of an approach for that. The same thing is true for independent variables x and y. We can think about another example here where we can go ahead and add the other value. Now remember, for the variance of something, it's actually a constant times something. There's a different rule, so you want to be kind of picking that up in terms of these different values. So working with differences, working with sums, again, there's some specific differences. It's important to be kind of looking to see the difference between 3x and the sum of three independent random variables. Are very different. This is often surprising for people. The just checking here kind of gives you a way of kind of seeing if you've been tracking things as you go along. There's a nice think plan approach to kind of see that. And then we'll be briefly talking. It's important to have some familiarity with this section on correlation and covariance. It's marked as optional, but you're going to be responsible for it in the course. It really thinks about these different properties for covariances, kind of a generalization of variance. And then really introduces what is happening when we have continuous random variables. Life is a little bit more complicated here, and we'll talk about how that happens. Here we're displaying the standard normal curve, something we're going to see fairly regularly throughout the rest of the course. And the idea of something that has probability 0 for every value, but that actually sums up to a total probability of 1. This is where calculus is going to be helpful in terms of trying to understand what is going on in terms of continuous probabilities. So we kind of close with a step-by-step example, packaging stereos, and then to kind of think about a think, plan, show, tell approach for a couple of different questions. Again, careful study here will be very, very valuable. Remember, we can calculate these z probabilities using the p-norm and q-norm functions. So kind of go back to chapter 5 if you have any questions about that. As always, check to see what can go wrong to good people, and also the learning objectives for this section. Overall, kind of still a fairly mathematical chapter, but some important foundations for what we're going to be doing